Okay, this is exercise 4D. This is for further maths, and this builds on what we were doing in class. I think everyone was there apart from Austin. So hopefully we know what we're going to be doing. This is called the Wilcoxon rank sum test. Now, those of you who were in, I did kind of warn you that it was quite similar to the Wilcoxon signed rank test that we did last time. Similar in as much, I mean, Ella's not going to like this, but just the name of them, it's easy to then get them confused. So you're going to have to get your head round what it is we're going to do with this Wilcoxon rank sum test. So let's get on with it. First thing to note is that last time, when we were doing this last time, the matched pairs part of this was critical for the signed rank test. So when it was matched pairs, we did signed rank. And that used a letter T, which we calculated and then used in the critical value tables. Now that is, matched pairs would be where you have a before and after situation usually. You have a group of people. It might be they are, well, I think the example I gave in class was the fact that you made them do a driving test. You then ply them with 10 bottles of beer and see how well they drive afterwards, and presumably they do worse afterwards than they would have done before. So this is the signed rank test, and you look for differences between the two. Now, not all situations are like that. So I've got an example here where I'm saying we may wish to see whether it's boys or girls who are the better drivers. So you can't do the same group before and after, because we've got a group of boys and we've got a group of girls. So this situation is called an independent group design. So you've got two independent groups. The boys is one group, the girls is another group, and we're testing to see if these are different. So this is not matched pairs, this is now independent groups, so we need a new test, and that new test is called Wilcoxon rank sum. Now unfortunately, usually in the exam they won't necessarily say use the Wilcoxon rank sum, sorry Ella, they'll say here's a scenario, you go, these are independent groups, therefore I've got to use the Wilcoxon rank sum test. So it's just a subtle difference between the two things. It tells us then, or it allows us to see if there's a difference between the two medians. So is the thing that we're testing, the score for the boys, different from the scores of the girls? And again, it might be a little bit different. You'd expect it to be a little bit different. Are they far enough apart? Are they significantly different? If they are, then we would reject H0, otherwise we do not reject the H0. Now there's a bit of a complicated scenario which we have to go through, and I'll just run you through the main parts of it. This kind of scenario is listed in the formula book, believe it or not, in almost as much detail as this. There are two samples of size M and M, and it's important which one's which. The smaller of the two is M. So that matters, because down here we use the M. It says rank all the values of both samples. So we basically take all the numbers from the small sample and the big sample. They could theoretically be the same size, and we'd have to make a decision, but I suspect yours will have one is less than the other. And we take all the numbers from both samples, we put them together, and we basically rank them from start to finish, and the lowest value gets a value of 1. And once you've ranked them, it then says we calculate this RM, and RM is simply the sum of the ranks of the smaller group that you've got. The temptation would then be to calculate the other sum of the ranks for the other group, but it's not quite as straightforward as it. We have to do this rather bizarre calculation. I'm sure Wilcoxon made all this up and just thought, someone will play along. But there you go, that's the calculation we then do. Remember what M and M is. M is the size of the smaller group, how many boys there were, and how many girls there were, for instance. And then once we've got the smaller of these two things, we call it W, and W then we look in the critical values to see whether or not it's small enough. And remember, the rule is the same as last time in terms of the value you get has to be smaller than or equal to the critical value if we're going to reject H0. If it's more than, we do not reject H0. Simple, once you get to that stage. So we've got a bunch of numbers here. So let me first of all, it says we've got a psychologist feels that men and women, men are better at abstract reasoning than women. And he collected scores for 5 women and 7 men. So notice the group sizes are different. So straight away I can just write that m equals the smaller one is 5 and the n is 7. That's important that we know that. We write out the hypotheses. H0 basically simply says the medians are the same. Your assumption is that they're the same, and it might in the exam be a bit more wordy here, but there's no context because I haven't got much space, but are the same. So the median for the men and women are the same, and by definition then my H1, my alternative hypothesis, is that the medians are different. Excuse me for my dodgy writing with this dodgy tablet. Apparently this is the good tablet, so I can't complain. So anyway, having got that, I'm just going to now list the women and list the men. And we're going to do my best. That's a dodgy straight line, but I use 81. So I'm going to go through all these numbers. I'm going to look for the smallest. Now that 60 is the smallest one, just quickly looking at them. So that gets me a 1. And the 69 I think is the next one. That's a 2. And I think the 70 is a 3. So on the face of it, the men are... I mean, it's hard to... It feels that men are better at abstract reasoning than women. It'd be interesting to see whether or not... See, I think it's more than perhaps men are different. I suppose the question is this a one-tail or a two-tail test? And I don't even know. It's a bit weird. I don't even know which way, whether it is a good score to be high or low. So I'm gonna just say here, men, median is better. I'm going to say I don't really know which way around it is. It might be like golf where the lower score is better. I suppose that question is not very well written. We'll put up with it for now. So anyway, I've got these scores, and the reason why I say all this, by the way, because effectively that's made it a one-tail test. And just checking quickly there, it says 5%, so I'll need to use that in a bit. Anyway, back to the ranks. So I've done the 60, I've done the 69, I've done the 70. What comes next? I'm just looking. I've got an 80 there, so that's presumably the 4. And the one next to it is the 5, so that's those two. Then the 82 is the 6. And, 85 is the 7. That's the 8. I've got a 9 there. 10, 11. Oh no, that's a 12. Nearly made a mistake. And that's the 11. Dum, dum, dum. And remember what I do is I calculate the RM. Now weirdly this is called M even though we've got women and men. This is RM is for the smaller rank, so it doesn't really matter that we call it women. So I add these up, I get 9, 21, 31, 38. Right, got that right. Let's just add that up again. 9, 21, 31, 38. I go with that. Now if you remember we had a rather weird formula. There it is here. It's this m plus n minus m plus n plus 1 minus the rm. So if I just do it now, it's m plus n plus 1 minus rm. Now if we do that, we get the m up here. I wrote them down, didn't I? It's 5 lots of. Now m plus n is 5 plus 7 is 12 plus 1 is 13. And then I have to take away the rm, which is 38. That's 5 13 is 65. Minus the 38. Sounds to me like 27. So I've got my value. I look at these two scores. I could use either, apart from I have to use the smaller one. The small one is obviously 27. And then I need a critical value. Now let's go to the critical value table. Now in the textbook, it's on page 204 from memory. I might have made that up. Let's just check. But obviously I'm going to put the 206. And you'll have to look in the table. Now the table in the formula book, which you've all got, but I will put on the spreadsheet, on the exercise sheet as well. The table is a two-way table. So on this one I've got, it's 5%, it's a one tail, M is 5 and N is 7. And I reckon there the critical value, just looking at it there, is 21. And so obviously I say 27 is greater than 21, therefore do not reject H0. I'd be expected to put a wordy bit on there as well. Yeah, you've seen the kind of things you have to do for the wordy bits. I'll just try and bear with me. Yeah, so the wordy bit here is I've just written it at the bottom. It says insufficient evidence to conclude that the psychologist was right. So on that basis, here's another example then. So example, the following data shows the results. I'm going to try and nip through this quite quickly. So we've got in a test, we've got 2 countries, we've got data regarding test results of students in a test. So anyway, we start off, we've got m equals 4, we've got n equals 5. Test whether there is a difference. So this looks much more like, and I'm going to write m, meds same. And this one, it's just the median is different, the meds different. So obviously you write that out properly. But it implies it's a 2-tail test, and it's 2-tail at the 5%. So bear all that in mind. We're going to do the ranks for the A and then the B. And my smallest number there, just looking at it, is 46, then 48, and 49, so that's 3 of them gone. 4, 5, 6, 7, 8, 9. Remember what I now do is I find RM, which is the smaller rank, added up, 10, 21. I now find this weird m plus 1 minus rm, which is obviously the 4, add them together 9 times by 10 minus the 21, so that sounds like 19 to me. And again, it doesn't have to be this way around. Again, this is the smaller one of the 2, so I'm going to say w equals 19. We need a critical value. Now the critical value will come from page 206 again, whatever it was, and you'll notice I need m equals 4. Again, looking at the two-way table, it's a 5% 2-tail. So 5% 2-tail, m is 4, n is 5. I get a value of n is, critical value is 11, I think. So let's check the answers in a bit to see if I got that right. Again, 19 is too big then. It's bigger than 11. So I'm going to do not reject. Reach not. And sometimes these non-parametric tests, and then the wordy bit again. If I just try and see what I wrote. 19 and 11, that's good. Since 19 and 11, do not reject H0. Insufficient evidence to conclude that there's a difference in the median of these two, the median test score in these 2 countries. It would seem, but just by the picture, it's meant to be Mexico and America. So this is what we're meant to do. You are going to do the exercise 4D from the textbook. Now I've got the exercise in front of me here. It's just the same. Questions 2, 3, and 4 are very similar to what we've done. In terms of you get a statistic. Sometimes you have to calculate the statistic yourself. Sometimes you have to. Question 1 actually is very similar as well. The question 5 is a bit different. You might have to think about that a bit. But I'll include some answers for you so you can have a read. And hopefully that's a useful first lesson. So obviously each time you're meant to have further maths with me or Miss Frovine, there'll be a lesson put up. And likewise with maths, every time you have lessons, we'll put up a lesson and you can then hopefully keep up to date. Let me know that you've watched this. Let me know that you've seen the homework. Do the homework. Send me the homework via a photo of your phone, an email, and I'll mark it and get it back to you. And that way we can make the best of a pretty rubbish bunch. And other than that, look after yourselves and I'll see you soon.